In today's lesson, we're going to be learning how to graph points from a table and then how to make meaning from those points. That's what interpreting points means. It basically means to make sense of it, relate it back to that story problem. All right. So we need to remember that ordered pairs are listed as x, comma, y. Okay, where x go left or right, and our y goes up or down. Okay, we always have to move left or right before we go up or down. So if we have a point that's like 3, 5, we have to go over 3 and then go up 5 to put our point. All right. All right, we are going to do examples of that simple equation where it's just a number times x, and then we're also going to do an example where it's like a number times x and then plus 5 or something. So first we're starting off with that simple example, that one-step equation. Anthony wants to buy his Hoops for Heart basketball team t-shirts to wear for their games. Each t-shirt costs $7.50. Identify the independent dependent variables and then make a table for Anthony buying 0 to 6 shirts. Then we're going to write an equation for the situation and graph it. All right, so the number of shirts, independent dependent variables. So we have number of shirts and total cost. Our dependent variable is the one that depends on the other one. So we'd put our dependent variable depends on our independent variable. So our dependent variable, the one that depends, is going to be the total cost because that depends on how many shirts he buys. Dependent. And then number of shirts would be independent. He can choose how many shirts he wants to buy. It doesn't matter how many kids are on his team. He could always, whoa, I did not spell that right. I can't write and talk at the same time. Independent. Okay. So he can choose how many shirts he buys. He doesn't have to buy it for the exact amount of people on his team. So the total cost is going to depend on that. Remember, our dependent is our y, our independent is our x. So you have x and y. You could also use the letters that they gave you, S for shirts and T for cost. But we should have that x, the shirts. All right, so we should have shirts and cost. I wasn't sure if I gave myself a box for the labels or not, but I did. All right, we want 0 to 6 shirts. So we go 0, 1, 2, 3, 4, 5, 6. And our cost. So if he buys 0 shirts, he's going to spend $0. If he buys 1 shirt, he's going to spend $7.50 because that's how much 1 shirt costs. If he buys 2 shirts, he's going to spend $7.50 plus $7.50, which is $15. If he buys 3 shirts, he's going to spend $7.50 plus $7.50 plus $7.50, which is going to be $22.50. Or you can notice that we're just adding the price of a shirt each time, so we're adding $7.50 to each of these numbers. So it'd be $30 plus $7.50 would be $37.50. And then plus $7.50 more would be $45. All right. So we've all done that part before. What we haven't done is the graph. Well, at least first we could write our equation. That's true. We know how to do that from the table. So it should always be y equals, and then think, what are we doing to our x to get our y? What are we doing with the number of shirts and the cost of a shirt? We're multiplying them, so we're taking $7.50 times x. Now to set up our graph, we've got to label it. Okay, so we can label the graph like Hoops for Heart. All right, our x should always go on the bottom. This is our x-axis. This is our y-axis, so our x are independent, which is shirts, should go on the bottom. And then going up the side should be the cost. Okay. Now we need to scale it out. Now it doesn't have to be scaled by the same thing. So if I count by ones on the bottom, I don't have to count by ones going up. Just on that one axis, it has to be scaled out perfectly. So on the bottom, we can just count by ones. It's 0, 1, 2, 3, 4, 5, 6. We probably could have skipped a line in between to spread it out nicer, but that's fine. For costs, we've got to go from 0 to 45. I would say let's count by like fives, and then we can just kind of like estimate where the point should be. That's okay. So let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Perfect. Okay. Now the reason why we do our tables with that X on the left side and the Y on the right side is that so that it's already an ordered pair. Okay, because it goes X comma Y. So this tells us we go over 0, up 0, and we put a point there. Then we go over 1, up 750, over 1, up to 750, that's going to be right about here, put a point. Then we go over 2, up to 15, over 2, up to 15. You should see it should form a pretty nice line. Over 3, up to 2250. That would be right about here. Oops. Then we go over 4 up to 30. Over 5 up to 37.50. Over to 6 up to 45. Now we do want to connect those dots to form a line because that would show us like, it doesn't really work for this example, but like let's say that this was like something that you could buy half of, or something that you could do like, if this is like hour spent, you could spend like a half an hour technically, and then that would show us where that like half point would be because it would show us on that line. So we do want to draw a line to connect all those points. And then we are done for this example. Now we do have an extension question at the bottom. What would it cost Anthony to buy 9 shirts? All right, so we're going to use that equation. Remember, X was the number of shirts. So what we're going to do is we're just going to plug in 9 for that X and solve it. So we'd have Y equals 750 times the number of shirts, which is times 9. Okay. You can use a calculator for this example. So we would do 7.50 times 9 equals $67.50. All right. This next example is going to be that two-step equation, okay, where we're going to be like adding something at the end, and then we're also going to be graphing 2 lines on the same graph. So this is like 2 new skills that are going to be in this example. Starts out the same though. We need to determine the independent and dependent variable for both situation, create a table, and write an equation for each person. So let's go through and let's do that. Leah and Olivia went to work out together at Lifetime Fitness. Leah burns 100 calories lifting weights and then goes to work out on the treadmill and burns 10 calories for every minute. Olivia decided to just run on the treadmill the entire time. So she's burning 25 calories every minute. So let's think about our independent and dependent variable. Which one is going to depend on the other one? And that's going to be our calories burned. Our calories burned, the total amount of calories that you burn depends on how many minutes they're spending on that treadmill. Okay, so our minutes on the treadmill is our independent. First, let's start creating a table for Leah. Okay, Leah was in purple, so I'm going to do all of Leah's things in purple just to kind of separate them a little bit. So I do have to label that this table is Leah's. I have my X and my Y. Remember, independent is X, dependent is Y. So I have my minutes on the treadmill and the total number of calories burned. I am going 0, 1, 2, 3, 4, 5. So let's look at Leah's. Leah burns $100. Leah burns 100 calories lifting weights, and then she goes to work on the treadmill and burns 10 calories every minute. So if she spends 0 minutes on that treadmill, how many calories has she burned? Well, she still burned that 100 calories from weightlifting. So 0 minutes on the treadmill, would still have her at 100 calories. 1 minute on the treadmill would still have those 100 calories from weightlifting, but then would also give her that extra 10 for that minute. So this would be 110. She spends 2 minutes on the treadmill. She has that 100 from weightlifting, and then she has 10 calories because she spent 2 minutes, so that would be 120. You're going to notice it's just increasing by 10 because we're just adding another minute, which is 10 calories each time. Let's go ahead and do that equation right away. How many? We have our y equals, and we're thinking about what are we doing to the x to get the y. Okay, we have something at that end that we're adding on every single situation. That's our plus 100. That's something that she burned those weightlifting calories. She can't get those taken away. Okay, once she burns them, she burns them. Then we have what's depending is our minutes on the treadmill are going to help depend on that calories burned. So we are going to take the minutes on the treadmill, our x, and multiply it by how many she burns every minute, which is 10. So we have 10 minutes times the number of minutes she spends plus 100 gives us each of these numbers. Let's walk through that. So she burns 10 minutes, 10 calories each minute. She spends 2 minutes. So we would do 10 times 2, that's 20. Plus that 100 from weightlifting, 120. So you'll see how that equation works out. We were just doing that all in our head when we were building this table. All right, let's do Olivia. Olivia just ran on the treadmill the whole time, so this is going to be one of those simple equations. She burns 25 calories every minute. She didn't burn any previous calories, so this will be an easier example than Leah's. We'll go 0, 1, 2, 3, 4, 5. If she spends 0 minutes on the treadmill, she's going to end up burning 0 calories. She didn't do anything beforehand. She spends 1 minute on the treadmill, she's going to burn 25 calories. 2 minutes, 50, 3 minutes, 75. You're going to notice we're just adding 25 because that's how many calories she burns every minute that we're adding over here. This equation, we should have y equals, and then what are we doing to our x each time to get our y? Well, we're multiplying it by 25. So 25 times x, or x times 25, same thing. All right, now we're going to be graphing these tables on the same graph. Okay, it's not going to be that different. So let's label the graph maybe like Lifetime Fitness. Down at the bottom is our x, remember, this is our x-axis. So that's our first column in the table. So that is minutes. Our y is our dependent variable. That's calories. I'm going to try to write this sideways. Not too bad. All right. And then, so our x is our minutes, 0, 1, 2, 3, 4, 5. Since I only have 6 numbers and I know I'm going to be able to skip here, I'm going to just skip a line. So here's 0, 1, 2, 3, 4, 5. You'll see later that our line is just more nicer and spread out. If you put it 0, 1, 2, 3, 4, 5, that would not be wrong by any means. It just looks a little bit nicer when it's spread out. For our calories, we have to look at both tables. Okay, so in Olivia's table, we're going from 0 to 125. In Leah's table, we're going from 100 to 150. So the biggest number we have to have is 150. Smallest number is 0. So I'm going to say, let's count by 20s, and it's not going to be a perfect number. Remember, we're going to have to estimate where those are, but let's count by 20s and see if that works out. That should work. Oops. Okay, we would be good. Now, when you're graphing two lines on the same table, you need to use different colors or different like shapes. So like if I didn't have a purple and a red pen, I could just use like stars for Leah's dots and just regular dots for Olivia. I could use like stars for Leah and triangles for Olivia. You could just use like different shapes instead of just a dot if you need to. And then just make sure that you'd like give that key up here and show me. Like I did my table in purple, so I know that my purple line is going to be Leah. You just have to tell me what kind of like code you're using for that. All right, so Leah has 0, 100. So we go over 0, up to 100, put a dot. Over to 1, up to 110, which would be right about here. Over to 2, up to 120. Over to 3, up to 130. Over to 4, up to 140. Over to 5, up to 150. We're going to connect those dots to make a line. So it shows that if she did like 1.5 minutes, she'd be right around here. Okay, now let's look at Olivia, which I'm going to do in red. She started at 0 minutes, 0 calories. 1 minute, 25 calories. Again, you're just kind of estimating the best you can where that 25 would be. 2 is 50. 3 is 75. 4, 100. 5, 125. Now we're going to connect to draw a line. Okay, so this is Leah and Olivia. Last few questions we have are just some interpreting points, meaning making meaning of points that were given. So what does the point 375 for Olivia mean in relation to the problem? Well, 3 is our x and 75 is our y. So if we're not given this graph and we're just asked what would the point 375 mean for Olivia in relation to the problem, it would mean that for 3, our x is minutes. So she exercised for 3 minutes. And our y is calories, so she burned 75 calories. Okay, so you're basically just putting like a label onto each of those numbers, making meaning of it in relation to the problem. What does the point 0, 100 mean for Leah? So what it means is she exercised 0 minutes on the treadmill, and she had already burned 100 calories because she did that weightlifting before. All right, big takeaway here is just how to graph that table on a graph, how to set up that X and Y axis, how to do your labels, all of those things. If you just heard that, that was Griffin. He's taking a nap and apparently is snoring. But yeah, so write a summary, just talk about that X, that Y, independent, dependent. You can maybe talk about how you interpret points by just putting on a label in relation to the problem.